All right, remember when we learned about friction? Well, we had the three cases. I'm going to go back to those notes up here. We had the three cases, different cases for friction. We had the case 1 where we were pushing on an object or applying a force to an object horizontally. That means even with the ground. And so the weight and the normal were equal to each other, and the applied force was to the right. And then the second case was the applied force is to the right, but it's up. And so when we lift an object up and then we start to pull it, the object still moves horizontally, but we decrease the amount of contact between the surface and the object, so our normal force is decreased or less than the weight. And then the third case, this was the case in which we create the most friction on an object, and that's the case where we push down and to the right. The object is still going to move to the right, but we're increasing the amount of contact between the two surfaces. So our normal force is increased. And again, case 3 is the case in which you have the most friction. Case 2 is your ideal. And if you think about moving furniture in your house, it moves better or smoother if you pick up one side of the furniture before you begin to move it, because you decrease the surface force. All right, so what we're going to be doing is we're going to be looking at these two angle type of problems because the normal force is no longer equal to the weight force. So when the normal force is no longer equal to the magnitude of the weight force. Now remember why I put this magnitude down? Why I put the absolute value around the weight is because weight is down, so it's negative. So this is what we're going to be looking at today. When the normal force is not equal. I'm going to do one problem and then you'll have a chance to practice problems. Remember to replay if you need it slowed down a bit. Okay, so we have our object. And we're just going to use a simple box. And the box is going to be lifted up and pulled. So we're going to lift the box up and we're going to pull it. So our applied force is actually on an angle. So here's our applied force. And let's say our applied force is 50 newtons. And the box's mass, let's give it a mass of 20 kilograms. So that's our mass. Remember, we measure mass in kilograms. Now we can definitely calculate the weights, and I would draw a free body diagram off to the side. Okay, so here's our scenario. And then here's our free body diagram. We use a dot. Here's our surface. We put a line in only if there's a surface. Okay. We have our weight, which goes always down towards the center of Earth. This is caused by gravity, right? And our weight is going to be the mass of the object times negative 9.8. So we take our calculator. And we get negative 196. And that's newtons. Now, if I was not pulling up at an angle, then my normal force would be equal to 196. However, that is not the case. My normal force is actually smaller. So I need to figure that out. Okay, so I'm gonna break a vector down. Okay, I'm going to break this vector right here. I'm going to break it down into two components. The two components are the components in the x direction. So this is component number 1. And then the other component is in the y direction. Now, every vector on an angle can always be broken down into an x and a y component. You learned this in projectiles. when you had an initial velocity of a projectile and you had to find the v in the y direction and the v in the x direction. It's the same scenario, okay? Or same idea. Now I'm going to say that we're going to keep this nice and simple. I'm going to say we're pulling this box up at an angle of 30 degrees. So do y'all see the right triangle that we've created there? Now here's where it gets a little bit sticky. This component is helping the normal force. Okay? That component is helping the normal force in the up direction. This component, along with the normal force, should be equal to the magnitude of the weight. Why is that? Because the box weighs or has a weight force of negative 196. If I pick the box up completely, straight up off the floor, what force do I need to pick the box up off the floor with? Hopefully you said 196 newtons, because that's how much the box weighs. So if I want to overcome gravity and hold the box in my hand, I'd be holding it with that force of 196. Okay, so the box is being held up by the normal force and by this Fy component. So now we get this kind of this new equation, and we'll come back to our triangle in just a second. Excuse me. We get the weight, magnitude of the weight force is equal to the normal force plus this Fy component. Kind of neat. So when we're trying to find friction, remember, friction is equal to, so this is a reminder, friction is equal to ma if we knew A, or friction is equal to me times normal. All right, so what we're trying to do right now is we're trying to figure out this normal force. So what is that normal force? All right, you guys get the picture? Then in the next video, I'm going to show you guys how to actually calculate the Fy so that we can find normal.